Alright, so now we're taking a look at finding limits analytically of sine and cosine. This is just the first part. Basically, when you're dealing with the limits of sine and cosine, there's two rules that you need to remember. Actually, I guess there's about 4 rules that you need to remember. And so I'm just going to go over those with you. First thing is, if you have the limit as x approaches 0 of sine x over x, that's always just going to be 1. Okay, and then these are kind of corollaries to that. So this is just sine of just 1x. But what if it's sine of like ax? Well, instead of 1 now, it would just be whatever that coefficient is right there on top. And that's when sine x is on top and x is on the bottom, but the reciprocal is the same thing. So x over sine x gives you the same thing. And if you had sine ax over sine bx, it would just be a over b. So really, you could kind of sum up like this rule and this rule and this rule. They're really all the same rule. You could actually just remember this formula and it would work, right? Because if the a is a 1, then that's a 1, and so these two are the same. This one's just a little bit different, right? This is the sine ax over sine bx, and it just equals the coefficient over the coefficient. It's pretty simple. So that's kind of like one rule, and then there's the second rule, and now there's this third rule. I know it's all kind of jumbled here. And that is if you have 1 minus cosine x over x. So 1 minus, that's important, the cosine has to be negative, of as x approaches 0, then that's just going to be 0. And again, the reciprocal is true as well. So if the x is on top and the 1 minus cosine is on the bottom, it's still 0. So this is the third rule. These 3 rules typically get you through any limit question with sine or cosine, as long as you have these 3 things memorized. So that's really all there is to these things, is we just got to memorize these 3 tools. So let's go ahead and give it a shot. Let's go through these questions. Okay, this first one. Well, now they're talking about tangent, but we didn't have any rule for tangent, but that's okay, because you guys are calculus students. You know what tangent is equal to. You can go ahead and write that this is actually equal to the limit. Got to leave that limit notation in there. X approaches 0. And tangent is the same thing as sine x over cosine x. And that whole thing is over x. And I'm going to write this as x over 1, because now I have a fraction divided by a fraction. And whenever I have a fraction divided by a fraction, I can flip and multiply. So let's write this as, let's write it like that. Okay, well, writing it like that means that I can kind of reorganize this now. That's the same thing as the limit as x approaches 0. And let's just, since I'm just multiplying here, let's put the 1 over here and the sine x over here. What would that look like? Well, it'd be 1 over cosine x times sine x over x. And there's a rule with limits. I don't know if we've really hit this or not yet, but basically you're allowed to break this up into 2 separate limits because we're multiplying here. So technically we could write this as the limit as x approaches 0 of 1 over cosine x times the limit again, x approaches 0 of sine x over x. Okay, well, now it's actually pretty easy. On the left here, this isn't one of my rules, but I can evaluate this really easily. What is the cosine of 0? Hopefully you kind of have that memorized. If you don't, I'm just going to go over here and sketch real quick for you. Remember that this would be 0, and if this was the unit circle, that coordinate would be 1, 0. So this is an angle of 0. And so and this is like your x, your y. So this is like your cosine and your sine. So really easily, I can see that the cosine of 0 is 1. This is basically a unit circle thing here. If you're not familiar with that, then this might be a little tricky. But all I'm really doing is just using my unit circle to say that the cosine of 0 is 1. So I can plug in this as it approaches 0 because I don't get anything weird here. I don't get like a 0 in the denominator or anything. So I can do that. So if I plug this in, 0 in for x, I have 1 over the cosine of 0 times, and this is my rule, right? This is the rule that I already know. Right here, this is just 1, so this is just times 1. And I already said that the cosine of 0 is 1. So this is really like saying 1 over 1 times 1. Well, this is not hard math now. The answer is just 1. All right. So we're going to do some similar techniques on the next one. I'd encourage you to just see if you can kind of play with it yourself, see if you can figure it out. But I'm going to go ahead and go right into it, but I would recommend pausing the video and trying it on your own. Okay, first thing I see here is this 1 minus cosine squared. We're really, really close to the reciprocal of this, and we know that it's the same thing as a reciprocal. So we're really, really close to just saying that this is 0. So what could we do here? Well, there's actually a few ways to attack this problem, but I'm going to just kind of show you how we can use factoring to solve this. See, I could write this as the limit as x approaches 0. And x squared is really like saying x times x over, and because this is a 1 minus, this is actually the conjugate rule. We could write this as 1 plus cosine x times 1 minus cosine x. Okay, well, here we have a similar situation where we could break this into two parts. I could write this as the limit as x approaches 0 of x over 1 plus cosine x times the limit as x approaches 0 of x over 1 minus cosine x. And that on the right is one of our rules. I know it's the reciprocal, but we already said the reciprocals are the same thing. So this here thing is 0. Well, that means that this whole thing is just 0. Well, 0 times anything is just 0. So I already know the answer without even working this part out. And I know it's going to be 0 because if I multiply anything by 0, it's 0. But I can prove to you how it is 0. Let's go ahead and plug it in. I get a 0 on the top, and I get a 1 plus 0 on the bottom. Well, 0 divided by 1 is still 0, and 0 times 0 is still 0. So we got our answer. Let's go on to the next page. Okay, again, this is just testing our rules. Do we know our rules? Remember these formulas here? If we have a coefficient in there, and it says x approaches 0, the answer is just that coefficient. It's really that simple. So this is just 3. That's really all there is to it. And I think you should be able to see what b is just by looking at the formula. It's the coefficient a over the coefficient b. Well, that would just be 3 over 5. Yeah, it's that easy. So if you know those rules, it makes it really, really easy. Some of these we're going to prove later on using something called L'Hopital's and some other kind of formulas and stuff. But for now, we're just memorizing these patterns here. Let's go on the last page. Okay. So how are we going to handle this guy? The 5 on the bottom is not the same thing as having the 5 inside with the sign. So we can't just say, oh, this is that rule. But what we can do is we can say, you know what? This is the same thing as the limit as x approaches 0. My arrow's kind of messed up there. Of 1/5 times sine x over x. And this 1/5 here, there's no x involved here. So this does not change as I approach 0. This is still just 1/5. Let me clean up my 5 there. So that means we can actually take this 1/5 and write out in front. Let me show you what I mean. I can write this as 1/5 times the limit as x approaches 0 of sine x over x. Again, I'm allowed to move that out there because there's no x in this expression. So multiplying it out in front or multiplying it inside here makes no difference. So we like to take coefficients and just bring them out to the front because it just makes the whole process similar. Well, now look, I have my pattern here. The sine x over x when x approaches 0 is just 1. So this is just like saying 1/5 times 1. Easy. Boom. Okay. Again, I would like for you guys to try this one on your own real quick, but not too bad. All we're going to do is kind of break down this factor real quick. And so we got the limit as x approaches 0. And I'm going to write this as sine x times sine x, because that's really what it means. And then on the bottom, I'm going to do 1 times x. Everything is equivalent, right? Sine x times sine x, that'd be sine squared x. And 1 times x, that's just x. So everything's the same. And now we can do what we talked about earlier. I can write this as the limit as x approaches 0. I could break it into 2 parts of just sine x, because that's sine x over 1, times the limit as x approaches 0 of sine x over x. Okay, well, now we're getting somewhere. I can go ahead and plug this in. There's no reason why I can't. The sine of 0, if I plug this in, I get the sine of 0 times, and I already know what this is, right? This is one of our patterns. This is just 1. So I get the sine of 0 times 1. So as long as we know what the sine of 0 is, we just multiply it by 1. We have our answer. Well, what is the sine of 0? Let's take a look. Unit circle. The sine is the y-coordinate. Here's 0. This coordinate again is 1, 0. This is the cosine. This is the sine. So the sine of 0 is 0. So this is just like saying 0 times 1. Well, 0 times 1 is 0. So that's it. Okay, we're going to add some little tricks and stuff to that in class, but that's all we're really doing when we talk about taking the limit of sine and cosine functions. All right, see you guys on the next video.